Hi everyone, today I'd like to present about this butterflies of the sea, and these butterflies are disappearing. So who are these butterflies? Pteropods. Pteropods are tiny planktonic sea snails. So they are zooplanktons, and they are known as butterflies of the sea because of the wing-like parapodia used for swimming. Parapodia is their extension of the body, and this tiny creature, it's just size of a lentil. It's spends its entire life drifting aimlessly in the shallow parts of the ocean. It's drifting because it's a plankton, and it will be spending its entire life in the upper layers of the ocean. And these pteropod is the common name, and they are actually of two types. First type is the shelled one, and we are discussing about the shelled pteropods. They are called thecosomes, and the other one without shell is called gymnosomes. So here I have a video of these pteropods. So this is how pteropods swim. So they swim using their extension, parapodia, and though it's a snail with shell, because of their movement, it's known as sea butterflies. And these butterflies, sea butterflies, they spend their entire life cycle in the planktonic stage. They will be like swimming in the water column, unlike some other planktons, which stay in their planktonic stage only during their early life stages. For these pteropods, especially these thecosomes, they are shelled during their entire life cycle, and they will be planktons. And let's see more about their key features. So it's about their size. They usually range from zero point 0.5 millimeter to 12 millimeter, but some species can reach up to 2 centimeter. And they possess very delicate, transparent aragonite shell. Aragonite is actually a crystalline form of calcium carbonate, but it is less crystalline. You know, by the word crystalline, it means like very well structured form of calcium carbonate, but it is a less crystalline one. So it's very soft. So this delicate transparent shell protects its body, and it has very soft body with the extension parapodia, which is used for swimming. And these pteropods, they're the common name, right? So they have different shell shapes depending on species. They may have spiral shapes or needle-like coiled or globular shell shapes. And about their feeding, most of these thecosomes, they are filter feeders. So using the mucus web, it can spread its mucus web up to 5 centimeter, and it can trap phytoplanktons or small particles around it and use it as a feed. And about their distribution, these pteropods, they are found globally from polar to tropical waters, but typically in the upper 300 meters of the water column. And these ones, they're very particularly abundant in cold, nutrient-rich waters, especially in Southern Ocean and Arctic waters. So, in fact, in Arctic waters and Southern Ocean, pteropods are the most or dominant form of zooplankton. And about their ecological importance, they are the major prey for fish, and especially in Southern Ocean and in Arctic waters, they are the major zooplankton. So fish like salmon, mackerel, and seabirds, whales, they depend on these zooplanktons for their feed, and they contribute significantly to biogenic carbon flux because it got the calcium carbonate shell, and these shrinking shells that will transport carbon to the deep oceans. Once it dies and decays, what happens? All this calcium carbonate sinks to the sea floor. So that's a biogenic carbon flux. And these species, they are indicator species of ocean acidification and climate change due to their shell sensitivity. It's very fragile, right? So it's an indicator of ocean acidification. So let's see how ocean acidification affects these pteropods. So you all know that what is ocean acidification? It's increase in the acidity of water, right? So increased carbon dioxide concentration in the atmosphere let more carbon dioxide dissolves in oceans, forming more carbonic acid, and it lowers the pH of seawater and makes seawater more acidic. So these acidic conditions, it will dissolve pteropod shells completely because aragonite is a very fragile form of calcium carbonate. So in this picture on the left hand side, this picture is actually from a experiment which was conducted in a lab. So as per reports, the expected or projected pH value around or towards the year of 2100 under high carbon dioxide emission scenarios is 7.8. So projected pH for 2100 is 7.8. So what scientists did, they have made an experimental setup with the ocean water of pH 7.8, and they put pteropod shells in those waters. And what happened is that this shell dissolved completely in 45 days. And in this picture, you can see that transition. So the very clear shell is on the upper left hand side. That's the original shell. It became like less thick, and then deformations happened, and finally within 45 days it dissolves. So if carbon dioxide emission continues like this, ocean acidification will intensify later, and this is going to happen for pteropods. Actually, in field studies, in some of the reports, it's already shown that the pteropod shell dissolution already started, and because of acidification, it can dissolve within weeks. So, what acidification, warming, and habitat loss does to pteropod is it slows down its growth and it increases its mortality. And these tiny zooplanktons, they're very sensitive to temperature changes. So this climate change affects the distribution, reproduction, and its survival rates. So some species are being pushed towards poles where conditions are more favorable. So in polar areas, temperature is much less. So some species or some pteropods migrates towards polar regions so that they can survive there. But it affects the food chain of water column in other regions as well. So let's see a schematic representation of Arctic pelagic food web. And I would like to show the tiny pteropods here. And these pteropods will consume phytoplanktons and detritus. They are filter feeders. So phytoplanktons will be consumed by pteropods and other planktons like copepods. These pteropods, though they are shelled, their shell is very soft. So other planktons, other predator planktons can consume them, as well as fish, or seabirds, whales, they consume these tiny pteropods. And you can see seals depends on fish, and polar bears, it depends on seal. So this is the complete food web, not complete, but a representation of a food web in Arctic region. And being the dominant zooplankton in these Arctic waters, destruction or change in the amount of pteropod is going to affect the food web drastically. And let's see some of the broader impacts. So, in acidic conditions, shells, these pteropod shells, they begin to dissolve or erode as we discussed. And once it starts to dissolve, or when more stresses are there in the water, what these pteropods have to do, they need to use most of their energy to repair their shell, and that will weaken their other body functions. So survival and reproduction rates will drop as the acidification increases. So studies in Pacific Northwest and Southern oceans have already shown wild pteropods with severe shell damage. So if there is decline in pteropods, it's not just if, it actually started to happen. So this decline in pteropods will eventually collapse the key tropic link, and there is potential cascading effects on fisheries, marine mammals, and carbon cycling. So it's a sign of broader ocean health issues. So to conclude, pteropods are tiny but very vital zooplankton species. Their disappearance is a warning sign of oceanic and climate distress. Protecting them is about preserving ocean life as a whole. Thank you.